What's up, guys? Welcome to General Electronics. My name is Clement, and today we're going to be talking about RF communications. Now, RF stands for radio frequency, RF communication are mostly used because of their capability of traveling a long distance and also capability of overcoming many obstacles out there. So this means they can go through walls, they can go through concrete, for example, they can go through clothes of all that kind of stuff, and because of their flexibility, so then they are mostly used also in a burglar alarm systems, smoke and fire alarm system, garage gates, and many other remote control systems out there. Okay, so today we're going to be basically talking about two ICs. The first IC is going to be for transmitting, and the IC itself is going to be HT12E Encoder, and the second IC is for receiving, and this is HT12 decoder. Okay, so we're gonna go ahead and experiment them in many in a different setup. Okay, and I also added some circuit for kind of safety purpose, also, which I will also explain in a bit. And with all said, I also compressed all information that you maybe require, or maybe you like to know about the two ICs under the description below. So you just check it up and look through, you can go through them, and you can have a basic understanding of how it's working. But of course, if you want to go deeper into the knowing exactly what's happening inside the ICs, then I recommend that you go to just download the PDF and you go through them step by step. But what I've gathered together here down the description below, it should be enough to help you to start with your projects. So I won't spend much time talking here, but I'm gonna go ahead and we're gonna start experimenting in many in different sections. And hopefully that I can cover all these sections in this short video. So cheers. Schematic, very basic, consists of the two ICs here. We have a couple of buttons from pin 10 to A13. These are inputs, and then this side of IC is the addresses, and this address have to match each other for you to get an output over here. Okay. So we have here LEDs as an output, but you can also put something else as an output, and also can also put here some kind of different input instead of just switches. Okay, RF transmitter. We have these ones here, but I know I'm using something different. I'm gonna be using the SYN 115, and the other one is gonna be SN 480. Okay, I'll put them on the description below so you can find them where I bought them. Okay, the operation voltage for the two IC, the first IC is between 2.4 volt to 12 volt, and then on the decoder is from 2.4 volt to 5 volt DC. Okay, so I'm gonna go ahead and show you actually, so this what's happening here is actually when you press the switch here, okay, you're sending a signal. Okay, you're sending a signal through these addresses. So then goes your signal to RF transmitter. You get your RF receiver, get input to the IC, and then only according to the addresses here, then you're gonna get your output. Okay. So if for example, if you ground pin 1 and 2 and 3, you have to do the same as well on decoder to get the output. We have a resistor, as you can see, from pin 15 and 16 of the encoder. The resistance is higher than the other on the decoder. Okay, this is the resistor. They are actually there to provide the necessary external resistance for the operation of the internal oscillator of the encoder. Okay, and the resistance on decoder, it has to be of, rather say, the resistance on the encoder, it has to be at least 50 times than the decoder over here, so that they can match up your frequency over here on the two ICs. Okay, So we're gonna go ahead and show you, maybe try to show what's happening here. Okay, so these are kind of a basic your inputs over here to the AC, okay, and then goes through the signal go through the RF transmitter wireless to RF receiver. The signal goes to the decoder and then get your output over here. So today we're gonna be experimenting in a different section. So the first configuration stays off until signal get detected to turn on the LEDs here, okay, and also the LED gonna blink as well. If I zoom a little bit here, you can see the difference here is that the anode is to the positive rail, and then the cathode is which is going to the AC itself, okay, and the other one is different, okay. The other one stays on till signal get detected to go off. So you can see the anode, it comes from the IC going to the ground, okay. So there's a difference, and we're gonna put up the same this setup so you see the different why and what result we're getting here. And at the end, I'm gonna try to combine these two outputs just to show you the difference of the ICs and the setup. So we're gonna go basically to the just a normal setup over here. Okay, as you can see, you have the transmitter here, and you can see it's very small one. Okay, if I zoom a little bit in there, if I can concentrate my camera. So you can see over here I have grounded pin 1, and then the rest of the pin as well. Okay, I've done the same also to the transmitter. Okay, so this is very basic, and you can see this setup now is actually the first one over here. Okay, let me zoom out a little bit. This is the first setup over here, okay. So anode come from the positive rail, and then cathode goes to the ground on the goes to the IC of the decoder. So this is now what we are going to experiment with. This is the transmitter. It's almost like it's actually look the same, okay. You can see the pins over here, they're almost the same on the addressor side. They are all the match. Now when I'm going to press the signal here, put the power on. So when I switch on the signal, you can see the LED is lighting, the first one, the second one, third, and the fourth. And then also the LED here is blinking. The very basic simple setup of the first ICs. So you can see the output here, everything stays off until I get the signal to go on. When I press the button continuously, the LED also continuously light. As soon as I lift the finger, then goes off. Second setup, and which is this one over here. So here, cathode, the anode comes from the IC, and the cathode goes to the ground. Okay, and this setup, everything stays on until it get the signal, until it get detected signal to turn off. So now we're gonna change a little bit of this here. So now I'm gonna change this. This is not correctly. Okay, and then I'm gonna ground all the cathode. There you go. So you can see they are all continuously lighting. Okay, you can see that I've grounded there, and then also on this pin here, you can see you can you can also put it a different setup. You can put like this to turn off, and then only blink when there's a signal. Or you can also do the same as like the other ones. You can also ground it. There you go. So you can see now this setup here, all LEDs are lighting, and then until I press the button, I get kind of, I don't know if you can see that, the LED kind of goes off. Okay, the second one, the third one, and the fourth one. I can do both. They all goes off. Okay, so this is also another different way of setup. Third setup, I'm going to try to mix the output over here. I'm gonna take two pin 10 and 11 on this side, okay, and then also pin 10 and 11 on this side. So I'm going to mix them and then see the different. So now it's too bright, a little just too bright. Maybe I should reduce it. I ground it on with the 10K, and then you can, so they won't disturb the camera much. Okay, now you can see two LEDs here, they are off, and the other one are on. So now this is a kind of a mix mode. Okay, I've mixed between the two outputs, the two setup. I've used two setup on this side and also two setup on the other side of the circuit. Now in this way, it can still it's still gonna work, but now you can see the difference. The one is off now, goes on. The second also goes on, and the third one goes off. Maybe I should zoom a little bit on this so you can see the difference. So this is now the mix mode. So if I press both of them, the other one turns on and the other one goes off. So now I have two transmitter here and one receiver. Our receiver is where we get our output, the LED gonna light, and then we're gonna transmit here with the two boards here. So I'm gonna connect power from this one here. And when I press the button here, of course, getting the LED is lighting. Okay. So I'm going to also connect the power on the receiver here, and then when I press the button here, nothing is happening on this transmitter. Okay. And here as well, nothing here. So, but if I disconnect one transmitter, then this one also it's working as well. Okay. So what we have learned over here is that we cannot use two transmitter to one receiver. Okay, it's kind of jamming the signal of I'm not getting the correct frequency to get our output over there because using two transmitter on the same addresses as well. So only one at a time it can work. I connect this one here, then you can see now I don't get any output over that side. Okay, and I disconnect this one here, then you can transmit with this one here. Okay, so again, of course, there's no wire between the two circuits. Okay, there again, nothing is happening until I disconnect one. So you can only use one transmitter to transmit signal to the receiver. Okay, so the second one now, I'm going to try to use one receiver and transmit to many different many setup as well, and see what we get the result for. So now we have here a receiver, 3 receivers here. Okay, their addresses are all the same. This is just connected the power to both of the circuits, and then here I have my transmitter. So if I press button here, all of them, they are at the same time. So I believe you can add more. You can add I think up to 8 receivers, and using one transmitter you can control both of the outputs. Okay. So this setup is very useful because then you can control many things at the same time, only using one receivers. Okay, as long as you put the address the same. Okay. So there you can see it's, so you can see this one is just very also basic, and the other one, but the third one is a bit complicated. It consists of more of there's a transistor in there, capacitor, and more wires. I'll show you also the next section why the difference is there. We have now established that we can use one transmitter to transmit to multiple receivers. Okay, so that's very useful. Circuit I added on this one here is this one here. Okay, this circuit I added. So if you ask me why I added the circuit here, I'm going to demonstrate to see the difference why I added. So you can see they're all lighting the same time. Okay, they're all doing the same things. Okay, so to show you the difference, first of all, I'm going to disconnect the switch off the power. Okay, this only transmitter, the power is here, so but the thing, there's no power in there. When I put the power on, you can see that this output here, the first one, they light continuously already, and I haven't even sent any signal. Okay, because here I've also disconnected the battery. Okay, so there's no signal being sent, and then you get output there. Okay, so when I connect the battery, then goes off. Okay, and then if I transmit signal and then I disconnect the battery over here, you can see that the LED there stays on. Okay, so this is not good. So the circuit I added is to kind of a safety purpose. For example, if you are opening something or you're switching something on and off, and then you have gone out of range of your battery on your transmitter dies, the circuit here is going to ensure that the whole system stays off. And we just see it here. If I disconnect the power over here, assuming the battery had finished I've walked out of range, then the output here, they're gonna stay on even though I'm not transmitting anything. So this is not a good setup. So with this circuit here I added, it ensures that everything, all those, it says off when there's no signal. That's why the circuit is there. And you can see the schematic how it is. I've added some delay circuit over here between diode, 10K, and capacitor here. Okay, and then the transistor BC547 and the LD. So if I bypass the circuit, if I remove this diode here and 10K and the capacitor, so I'm gonna zoom in there a little bit. Okay, so I'm gonna now bypass the circuit here. If I disconnect this and I connect there, it's still working. Okay, and then if I press one switch like this continuously and I press the other one, you can see the problem over here. We have an issue. This LED is blinking, is going off and on very quickly. So this is not good. So it's kind of a signal is being interfered. Okay, and then so if I had a circuit here, kind of a delay, then the problem is solved, as you can see. Okay, this is continuously light, and then the other one also light accordingly. The button according to the pressing of the buttons. Okay, so this is really very useful. I'm gonna also be using this setup very often because of the capability of safety, you know. So if I press button like this, all of them, and I disconnect the battery over here, the ground, then you can see it dims out slowly and goes off, and the other one stays on. So you don't want to be opening things, switching things on and off, and when you have worked out of range of your of the battery dies, the thing to stay on when you're not there to see what's happening. So with this circuit is always ensure that things stays off when there's no signal. So if I put the signal back again here, then the other one goes off. I also switch off over here. I disconnect the battery. I switch on the power supply. The first one goes off slowly, and the other one light on continuously, even though there's no signal in there. So this is kind of a problem we're having there. So if I put again the ground here, I connect the ground and the transmitter like so, then the other one goes off. So this is a safety purpose, safety circuit I added there to operate things correctly. So this is gonna be the last video about this experiment in this different setup.